Students, in this class we will be studying about modulus of a complex number. Now, if you are given a complex number, say z equal to x positive iy, then its modulus, is actually defined like this. You got to place z inside these two lines, and that is equal to square root of, you square the real part and you square the imaginary part, which is rewritten as root of x squared positive y squared. So this is the modulus of a complex number. Now let us do some questions. So we are given a few questions. So the first one is, say if z is equal to I, then we are expected to find the modulus of z. Now z is equal to I, the meaning is z is equal to 0 positive I. This is the meaning of this. So therefore the modulus of z is equal to root of 0 squared positive. The coefficient of I is 1, so you have to write that one and square it. So this is equal to root of 0 positive 1 squared is going to be 1, which is equal to 1. So therefore the modulus of z when it is equal to I is 1. So this is the answer to the question. So let us go and do the next question. Say we are given z to be as negative 12i. As I said earlier, the meaning of this is 0 negative 12i. So the real part is 0. So therefore the modulus of z is going to be root of 0 squared positive. You square the coefficient of I, which is negative 12, and raise it to the power 2. So this is equal to 0 positive. 12 squared is 144. So the value is going to be 144 with the square root on. So therefore the modulus of z is root of 144. And you stop with that. You don't need to do anything. Of course, I know the root of 144 is going to be equal to 12. So you can write that. But in case, instead of 144, if it lands up at 143, you don't need to use your calculator and obtain the value for root of 143. So have that in mind. So now let's move on to the third question. So we are given z to be as 12 negative 5i. So therefore the modulus of z is going to be root of 12 squared added with negative 5 squared, which is going to be root of 144 added with 25, which is square root of 169. So this is the modulus of z. But of course we know that the root of 169 is going to be 13. So therefore the modulus of z in this case is 13. So these are the important points that you have to know. I also want to stress on another important fact, that is modulus of z, when you raise it to the square 2, or in other words when you raise it to the power 2, then the outcome is going to be z multiplied with its conjugate. So z bar is nothing but the conjugate of the complex number z. So I'm going to show that to you how this is true. Now let us take, this is the proof for this result. Now let us take z to be as some x positive iy. So therefore the conjugate of this complex number is going to be x negative iy. Now let me just consider z multiplied with z bar, which is going to be x positive iy multiplied with x negative iy. I already given you the formula. The outcome of this is going to be x squared positive y squared. So this is z multiplied with z bar gives me x squared positive y squared. Now let me consider now, now we consider, say, modulus of z. Modulus of z is nothing but root of x squared positive y squared. This is the modulus of z. Now squaring both sides, we get, so what happens when we square both sides? This is going to be modulus of z squared is equal to root of x squared positive y squared, and you raise it to the power 2. Now clearly the radical sign, square root sign, and the square, they both get cancelled out, giving me x squared positive y squared. Now if I were to name this as 2 and if I were to name this as 1, comparing 1 with 2, we see that both of them are equal, right? X squared positive y squared, x squared positive y squared, both of them are equal. So we, from here clearly we see that z multiplied with z bar is equal to modulus of z raised to the power 2, and hence we have proved the result. Okay, so this is a very important result you have to know in complex numbers, and it will be of much use as you move on. Students, in this class you are going to be studying some properties related to modulus. So the first property is going to be modulus of z is going to be equal to modulus of its conjugate. Okay, so this is a very important property and we have to show that. Now I'm going to give you the proof here. Now let me take z to be as some x positive iy, and clearly z bar is going to be x negative iy. Now consider now the modulus of z, which is nothing but root of x squared positive y squared. Okay, now consider the modulus of its conjugate. So that's going to be root of, is going to be x squared positive, the coefficient of I is negative y, so you square it, so that is going to give you x squared positive y squared. If I were to take this as 1 and this as 2, comparing 1 with 2, we find that, or we see that clearly modulus of z is equal to modulus of its conjugate. Okay, so both of them are root of x squared positive y squared, and so they are equal. So this is the first result. I have shown you the first result.